on a tube light or a bulb. So if I focus on LED, what kind of data do I get from LED? Can anyone tell me what kind of data I can get from LED light or bulb or maybe anything? What kind of data I can expect from these things? Okay, so first one is the state, either it is on or off. Second one is the power consumption. Right? Third one is the intensity. Are you able to understand the writing? I mean, like it's just the iPad or stuff. So,
Yes, sir.
okay.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes.
Yes, sir.
So, great, thanks. So, everything around us has some data to share, and with the help of IoT, we get this data on our mobile devices so that we can control or monitor these devices to make our life convenient, to make our life much more secure. So, if you can see, like these are the two, I mean, like these are two simple things, the LED and the bulb or maybe any kind of light source. So these things are giving us the data about their state, either they are currently on or they are currently off. They can also share the power consumption, how much power they are consuming, is it 10 watts, 20 watts, 30 watts, whatever it is. Then they can also share the intensity, the how lux value is there, how much lumens are there. So these are the things that we need in our life as of now to make our life much more secure and much more comfortable. We can use these things to create multiple applications. And similarly, let's say if you look at the door, what kind of data a door can give you? Again, it's state, either it is open or it is closed. So why do we need this data? Again, to make our life secure and to make it like convenient. So if I have, let's focus on these two things. If I have like a combination of smart door and a smart bulb, what I can do, what I can create an application out of these two things. If I have a smart door and if I have a smart LED, what can I do? What is the possible application I can derive out of it? So there is this one application that I can do. Let's say whenever I open the door, my LED just turns on automatically, and whenever I close the door, the LED turns off automatically. Some kind of application that I can deliver. Now again, if you are not sitting at your place, if you are far away from your home or you are far away from your office, if you have a notification that someone opened your door and someone closed the door, it can be useful for a security point of view as well, right? So these are the multiple applications that we can derive.
Okay, okay.
Ravi Kiran, I guess. Uh, okay, thanks, Ravi. So these are the applications that we can actually get out of IoT. So these are very small things that we can derive. So now let's focus on the architecture of IoT. So the architecture of IoT basically consists three different things, or I would say three different layers. The first one is perception layer. Second one is network layer. Third one is application layer. So we'll study these three different layers of IoT one by one. So let's talk about the T in IoT. All the things, literally all the things, comes under this perception layer. The basic layer or the fundamental layer of IoT is the things. You have to make the things smart. So you have to have a hardware for IoT. Hardware, or you can say the point of data collection, where you want to embed these sensors and microcontrollers to get the data or to perform action on some kind of device. So all these devices or all these hardware or all these things, I would say in a layman language, all these things are under this perception layer. Now this perception layers is further divided into two parts. First one is sensors and actuators, and the second one is microcontrollers. Okay, so this can be a little tricky for the computer science students since they are not in touch with the hardware part. But I'll try to explain.
Hello.
Are you able to hear me?
Yes, sir, you are audible.
Okay. Okay, so the first thing is sensors and actuators. Then we have microcontrollers. So sensors are those devices which convert the environmental values, or we can say the physical values, into some electrical or digital signals so that our microcontroller or a computer can process those signals. So let's talk about force, or let's talk about temperature or humidity. These are the environmental data. It's not in digital form. So sensors are those devices that sense that data and convert it to some electrical or some digital signals so that our microcontroller can process that data and can perform operations accordingly to that data. Because since it is a computer, microcontroller is a kind of computer, so it will be performing data on some signals only. It will not sense itself that okay, the temperature is this 22 degree or 25 degrees. It has to have some digital values so that it can process, and it can process that data, and to show us like what kind of applications we can build out of it. So sensors are those devices which convert your physical data into some kind of electrical signals or digital signals so that we can use that data in our microcontrollers or computers or our processors or SoC devices. Actuators are those devices which convert your digital data into some kind of mechanical motion. For example, your motors. You give command to your motor, you give electrical signal to your motors, and your motors uh, uh, just convert it to some mechanical motion. So actuators are those kind of things. Now, talking about microcontrollers, microcontrollers are those devices which have onboard RAM, ROM, and all the peripherals like timers and your processor and your oscillators. All these things on a single chip, so it acts like a mini computer which can perform operations according to the data that we are providing it. So let's take the example of a simple, let's say, light bulb, and here we have a light bulb, and we need to convert this normal light bulb into a smart light bulb. So if I need to convert it to a smart light bulb, I need to connect this light bulb to the cloud network, or you can say the internet. Okay, so the process starts from this stage only: sensors or actuators or microcontrollers. So since the light bulb is a hardware, we need to integrate it with some kind of microcontrollers and some kind of sensors to connect it to the cloud or to the internet. So let's say we have a light bulb. Now we need to make it a smart light bulb. Then we will be using, let's say, lux sensor to calculate the lux or the brightness of the LED. Then we need a microcontroller. So is someone doing this on purpose? Am I audible again?
Yes, sir, you are
Yes,
audible.
sir.
Yes,
Okay.
sir.
So we have a light bulb, then we connect it with a lux sensor and a microcontroller. Then this combination of the basic hardware, the non-smart thing, with some kind of sensor, with some kind of microcontroller, this comes under the perception layer. Are you able to understand what is the perception layer? Yes or no?
Yes,
Yes,
sir.
sir.
Perfect. So this is the part for the perception layer where our hardware resides. Now coming back to the second layer, which is the network layer. Now we have a combination of a device in which we have a basic thing that we want to automate or we want to make it to smart. Then we have a sensor. Then we have a microcontroller to perform operations accordingly. Now coming to the network layer has again different layers. One is the communication protocol, or you can say the communication technology. Second one is the gateway. Network layer has three different layers. Again, one is communication technology, second one is gateway, and the third one is cloud. Can anyone explain me what do you guys understand by the term cloud computing and what exactly is the cloud? Anyone?
Stores
Storage of the
data.
data, sir.
Storage of data is a good answer, but it is not the
Virtual, virtual storage, sir.
yeah, virtual storage is a good answer, but again, it's an application of cloud. It's not exactly the definition of cloud. Any other guesses?
Where the used data is extracted and is used for performing some other functions.
Uh, Again, it's an application. Okay, so I'll explain. So whenever someone asks you in any interview question or anything, cloud is a combination of three different things. You can directly answer these. Cloud is a combination of SaaS, PaaS, and IaaS. What are these three terms? First one is software as a service. Second one is platform as a service. Third one is infrastructure as a service. So let's uh, let's try to understand this thing with an example. Let's say you want to convert a PDF file into a Word file. So there are two options that you can do. Either you can download a software which can convert the PDF file into a Word file, or you can go online. You can directly type PDF to Word converter, and you will be seeing a website. From there, you can just upload your PDF file, and it will give you the Word file of it, right? So in this architecture, what you are exactly using, you are using the software as a service, because you don't have to install the particular software in your PC, and you have to install it, and you have to perform operations on it. You just go to a website which is a kind of software as a service that is provided by some other company, and you are just uploading your PDF, and all the work is done at the cloud level. You don't have to install the software. So that is a software as a service. Platform as a service, where you can use a complete a single platform, either it be a gaming platform. So there are multiple gaming platforms currently available in which you don't have to install the game at your PC itself. So there are different kind of platforms that are available. So second one is the platform as a service. Third one is the infrastructure as a service, where you don't even have to spend money on buying the hardware. So let's say if you want 1000 TB of 1000 GBs of hard drive, and you want 16 gigabytes of RAM, and you want a 16 GB of GPU. So these kind of stuff, either you go to the market or you buy it for yourself, or you can rent a complete infrastructure on the cloud. So that comes under the infrastructure as a cloud. So those things like virtual storage and these things, those are the part of this IaaS, which are providing you a complete service. So that is not exactly the cloud. A cloud is a combination of software as a service, platform as a service, and infrastructure as a service, which is providing you different services, where you don't have to spend money on infrastructure, platform, or softwares. Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, great.
Yes, sir.
So far we have taken a device, a normal thing. So this light bulb is a normal thing. We have added a lux sensor to calculate its lux or lumens, or then we have connected it to a microcontroller so that we can perform operations on this data. A microcontroller will also control this LED with the help of some relays. Okay, so this moreover, these are the three basic things that we need in the perception layer. Now in the network layer, we were discussing about cloud is a third part of network layer. We have gateways and we have communication technologies. Now let's coming to the communication technologies. Okay, again am I audible?
Yes, sir.
Yes, sir.
Okay. Okay, so let's speak about the communication technology. If you have a laptop and you want to connect it to the internet, what kind of different hardware, or what kind of different ways you can do it? And answers quick.
Ethernet cable,
Use a modem.
modems.
Right, Ethernet cable, modem and Ethernet cable is a kind of same thing. Second technology.
Wi-Fi.
Wi-Fi, perfect.
In mobile data.
Mobile data, got it. Absolutely right. Any other thing that we can use? Any other option?
Connection, sir.
Pardon?
Yeah. Bluetooth.
Bluetooth tethering you are saying, right? But again, Bluetooth tethering is a just a medium. Eventually, you are using a SIM data, right? So right now, if you want to connect anything to the internet, you can either use GSM, you can either use a Wi-Fi, or you can use a LAN cable, right? So these are the communication technologies that we use to connect our devices to the internet. Now there are some different other communication technologies in IoT which we use to connect our devices to the internet apart from these three. So since this smart device that we are making, it's a compact device that will go inside your home, or it can have multiple applications. So we can't just rely on these these three technologies, just Wi-Fi, LAN and GSM. So in IoT we have multiple other technologies as well, such as Zigbee, such as uh, NRF, such as Zeta waves, such as Bluetooth or Bluetooth low energy. Then we have long range, which is LORA. So these are some of the technologies that we use to connect our devices to the internet. But again, the basic technologies are these three because these are providing you the direct access to the internet. Are you able to understand what exactly am I talking about here?
Yes, sir.
Yes, sir.
So
Yes, sir.
eventually everything has to route from these other communication technologies to the either GSM, Wi-Fi or LAN. I'll discuss it again. So let's say, coming back to this device, let's say we have created a device. So this is our, let's say, smart device. Now we need to connect it to the internet. Then we need some kind of communication technology here. So in this situation, in the present scenario, we have GSM, Wi-Fi, LAN. So here I have two cases, one and two. If I use a Wi-Fi modem, let's say if I use a Wi-Fi module, and Wi-Fi module, I have examples like ESP12. How many of you guys have worked on ESP12? Have you worked on ESP12, or do you know about ESP12? What exactly is a ESP12? Okay, I'm seeing people are raising hands, so that's a good news.
Yes, sir.
Okay, perfect. So for those who don't know what exactly am I talking about, so ESP12 is a microcontroller, which is a Wi-Fi based microcontroller. So the microcontroller that we have used here, it's the same thing, but it has Wi-Fi in it. So you have a Wi-Fi modem along with the microcontroller. So in the next class, we will work on ESP12 microcontroller itself, and we will be connecting one LED to the internet, and we will be operating it with SmartDen.tech. So I'll be taking two cases here. One is the Wi-Fi module, and second one is, let's say if I don't use any of these GSM, Wi-Fi, LAN, if I use, let's say, BLE. BLE is a Bluetooth low energy, or Zigbee. So let's say if I use Zigbee or BLE, then in two cases we will discuss how the things will happen. So this is my smart device. It has a microcontroller, it has a sensor, and it is a light. So these are the three different things that my smart device has. Now, if I use a Wi-Fi module ESP12 with it, it can directly connect to the internet. No issues. It will directly connect to the internet because we can just provide the Wi-Fi SSID and Wi-Fi password to this Wi-Fi module, and it will directly connect to the internet, and we can access the data, whatever the data we have, like the state of the LED, like the lux value, and if we use some other sensor, then we can also get the power consumption. So these are the things that we can access if we use the Wi-Fi module directly. Now let's talk about the Zigbee. or the BLE. So these are the two different technologies that doesn't connect any device directly to the internet. Uh, any questions? I request if you guys have another call to attend, please mute yourself before that. Okay, thanks. So let's say we use Zigbee or BLE. So these are the technologies, these are the transceiver modules basically. So this is for all the electronic students and electrical students. Any of you guys can explain me about the transceiver module? What is a transceiver module? Question for electrical
Sir,
and
module.
electronic. Yeah, please.
Transfer the data.
Okay, that transfer the data. That is a very
Sir,
vague term.
they transfer and receive the data.
Absolutely. Abbas, I guess. You have answered this
Yes,
question.
sir.
Great, Abbas. Okay, so basically for other students as well, let's say this is a device antenna and this is your device 1 and this is your device 2. A transceiver module is a device that sends the data to another device and receives the data from another device. So it can perform both the operation. It can send as well, it can receive as well. So these are basically the transceiver modules. So here we have these different technologies, these Zigbee, NRF, Z-Wave, Bluetooth Low Energy, LoRa. These are all the transceiver modules. Transceiver modules. So basically, if I use a Bluetooth module or if I use a Zigbee module, it will only transmit the data to another Zigbee module. So if I am using a Zigbee module, it will only communicate with another Zigbee module. If I am using a Bluetooth module, it will only communicate with another Bluetooth module. So the Bluetooth module cannot communicate with Wi-Fi. The Bluetooth cannot communicate with an RF. It cannot communicate with Zigbee. It has to be another Bluetooth module only. So to overcome this situation, we have this second layer, which is called the gateway. Now, if we use these two things, these two modules, either Zigbee or BLE, we need to use a gateway, which is called the IoT gateway. And let's try to understand the gateway. I'll draw a figure here. So let's divide the gateway in two different parts. This one is input and this one is output. We know that we need to connect this output part to the internet because eventually we need to transfer this data, whatever the data that we have here, we need to transfer this data to the cloud or to the internet. In the first case, we have Wi-Fi module which directly connects to the cloud and we can directly you know uh, transfer the data from our device to cloud. Now in second case, we have Zigbee or Bluetooth module which cannot directly connect to the cloud. There has to be some medium by which they can transfer the data to the cloud. So that medium is a gateway. And how gateway works? So let's divide the gateway in two parts. One is the input part and second one is the output part. So we know that at the output end, we need to connect this gateway. This gateway is again a physical hardware device. So we need to connect this gateway to the internet. And anything that you need to connect to the internet, it has to be either by using LAN or by Wi-Fi or by GSM. So at the end point of the gateway or the output part, we have to use these three technologies, either one of them. Either the gateway must support Wi-Fi, or it must support LAN, or it must support GSM. So at the input part, if we are using a Zigbee device, we must have a Zigbee device. And if we are using a Bluetooth device, we must have a Bluetooth device. And if we are using NRF, we must have NRF modules as well. Now you must be thinking that if eventually we have to use a Wi-Fi, GSM and LAN, why don't we just go to directly to the Wi-Fi module and don't use the gateway at all? So there are few different things that we need to take care while creating this IoT device. So if I use any of these technologies, Wi-Fi, GSM or LAN, they consume a lot of power. So Zigbee and Bluetooth Low Energy, these kind of communication technologies are specifically you know, uh, they are specifically designed for IoT purposes because they are consuming very less power, and we can even run a single device on batteries for a complete year. So if I use a single cell, I can run that device on Bluetooth Low Energy for a complete year. I don't even have to replace the batteries. So that is the reason we have to shift to these different technologies. And there are again multiple factors. First can be the range. What will be the range of Zigbee and Bluetooth Low Energy and Z Waves? It totally depending upon your application, the type of device you are making. We have to choose the these communication technologies. Wi-Fi is bound to 30 meters or 40 meters maximum. Zigbee is more than that, and NRF is again, it totally depends on different technologies. Long range is about more than 1 kilometers or 10 kilometers line of sight. So depending upon the type of application that you want, you can choose these different modules. Now, first one is the range. Second one can be the battery consumption. If the device is a battery powered, you must have to, take care about the, the time on which you need to recharge the batteries again and again. So this is another factor that you need to take care while developing an IoT product. Another one can be the cost. Obviously, when you are making a product, you have to think about how costly it is, or you have to make it affordable for the people or your target audience. So there are multiple factors which leaves us that we need to either shift to Zigbee, then we need to either shift to NRF or BLE or another communication technology. That totally depends on application of your product. Another important factor can be the topology. Okay, computer science students, can anyone explain me about the topology itself? What is the topology? Computer science, IT, electronics, maybe?
It is a hardware connection between different systems.
Absolutely, great. Uh, so topology is basically how you design your network. So either it can be a mesh topology or it can be a bus topology. So topology is another factor. In Zigbee, you can create a mesh topology. So let's say if you are using multiple devices, 5 devices, 10 devices, 20 devices in your house, they can individually connect to each other and they can create a much bigger network than Wi-Fi itself. So you can create up to 90, 100 devices on Zigbee. So again, it totally depends on type of application that you are making, that you need to shift to these different technologies. Now, coming back to our model, which is if we are using this Zigbee or Bluetooth, we need to have a gateway, which is a combination of two different hardware modules, Zigbee plus either Wi-Fi or LAN or GSM or Bluetooth or NRF. So Samsung Smart Things is a hardware gateway which you can just search about on Google. Okay, now any questions till now? Any questions for network layer?
No, sir. No, sir.
Okay,
No, sir.
No,
okay,
sir.
okay. Perfect, great. So I'm going to ask a question now. I told you that these are the yeah.
I had it.
Any questions?
So the gateway acts like a buffer, basically between a fellow Zigbee model and Wi-Fi or LAN that we use to
Yes,
connect it to the internet.
yes.
Okay.
Okay, Daksh, it is right. Great question,
Yes.
Daksh. Not exactly the question, but I'll ask the question on basis of this. So I told you that Zigbee and Bluetooth, these are the communication technologies that connects with another Zigbee and another Bluetooth. Okay, so these are the transceiver modules. But here in the gateway, I've used this input and output part. And here I have this Zigbee that is either connecting with LAN, Wi-Fi, or GSM. Can anyone tell me how it is happening? I mean, like how this thing is working, because it is also having a Zigbee and a Wi-Fi. Then how this Zigbee and Wi-Fi is communicating?
The
Can
data
anyone?
is converted, sir.
Pardon?
The data is converted.
Data is not converted. I mean, in some sense, data is converted, but how
Like
exactly it is happening?
the form is converted, but the data remains same.
Uh, that's one way of saying it, but it's not actually the right
Is
answer.
there
But yeah, please go ahead.
is there a form of an interpreter or a compiler which is in between the two?
No, there is not. Again, the same
We
thing.
can
Yeah, please.
can we integrate it since like the Zigbee and the Wi-Fi?
Yes, that's one way of saying it. We can integrate these two devices, but there is this thing. I've told you that, let's say this is Zigbee and this is your another Zigbee module. So they can communicate them with each other wirelessly, right? There is no wires in between them. But when we talk about this gateway, there are wires between them. One Zigbee module is connected with another microcontroller or a Wi-Fi based microcontroller, which has communication, interfacing protocols. Now, what we call them as interfacing protocols. And if you guys have worked on Arduino or any microcontroller, you guys must have heard about this UART, SPI, I square C. So these are the interfacing protocols by which we interface or we integrate two different microcontrollers, two different modules to each other. Let's say, and these communication happens through wires. So let's say if you have this Zigbee module and you want to integrate it to a Wi-Fi module and they both supports UART, then you only need two wires. One is for the TX wire, second one is the RX wire. The Zigbee's TX wire will connect to the Wi-Fi's RX wire, and the RX wire of Zigbee will connect to the TX wire of Wi-Fi. And that is how this UART protocol works. And your Zigbee is now connected to the Wi-Fi, but through wires and through a proper integration. Any doubt in this? Is it clear how the gateway works?
Clear, sir.
Yes, sir.
Perfect.
Yes.
So can you repeat that?
Is there any
These two
special
wires.
wire used for these two?
Yeah, I'll repeat, Gaurav, and someone is asking a question. Please go ahead. Sanjay, you are asking something?
No, sir.
Okay, so if there is any question, you can just ask. Okay, so Gaurav, I'm repeating this. Basically, what is happening here? So this is your device one, or I'll say Zigbee one, or this is your Zigbee two. So these two Zigbees are communicating with each other wirelessly. There is no wire in between them, and they are communicating, they are transferring the data between one module and another module. Okay, now we need to transfer this data to Wi-Fi. At this point, Zigbee cannot transfer the data directly to the Wi-Fi wirelessly, but it can integrate with a Wi-Fi module with the help of some interfacing protocols. And these interfacing protocols are UART, SPI, I2C. These are the three basic interfacing protocols. There are some other protocols as well, but all the microcontroller supports this UART, SPI, and I2C. These are the most common interfacing protocols. So Zigbee module, again, when I talk about a module or when I talk about a microcontroller, uh, you guys can assume that I'm talking about a device which has some pins on it. I'm not sure if you have studied about microcontrollers in your semesters, but if you are from first year and second year, you guys will study about the microcontrollers. There is a complete subject in engineering, and on that particular subject, you will get to know how to integrate these microcontrollers. What are the different pins? So when I talk about any Zigbee module or any microcontroller, consider a hardware which is having multiple pins. So these pins, we can use these pins for different other to perform different other operations, and these are defined for performing different operations. So there are GPIO pins, there are this interfacing pins, and there are power pins, and there are analog pins. So there are different types of pins which performs different operations. So here we have, for UART, we always have these two pins in all the modules and all the microcontrollers. So in the Zigbee module, we will connect the TX pin of Zigbee to the RX pin of this microcontroller, Wi-Fi microcontroller. Then we have RX pin of Zigbee, which we will connect to the TX pin of.
You're muted, sir.
Am I audible now?
Yes, sir. Now you're audible.
Yes, sir.
Okay, okay. So, hello. Uh,
Yes, sir. You're
Yes,
audible.
Yes, sir,
you're
you are
audible,
audible.
sir.
Hello. Am I audible now?
Yes, sir.
Yes, sir.
Yeah.
Yes,
You're
sir, yes,
audible.
sir.
I was just hearing my voice again, so I just okay. So now these modules are having these communication protocol pins, SPI pins, I2C pins, UART pins. So we just need to connect those pins to another microcontroller or to another device that we want to integrate it. Is it clear?
Yes, sir.
Perfect. So now we have studied both the cases. If we use a Wi-Fi module directly, then we can directly connect the device to the cloud. And if we are using a Zigbee or Bluetooth module, we have to route it through a gateway, which will eventually connect the device to the internet. I hope everything is clear till now.
Yes,
The
sir.
Yes, sir.
perception layer is clear, the network layer is clear,
Sir,
communication
I had just one
technologies.
doubt.
Yeah, yeah, please, please.
Sir, like, sorry, I think you would have to repeat. Sir, after this Zigbee Bluetooth
Uh-huh.
model, you have shown this box of input and output. Okay.
Yes,
So,
yes.
and your doubt was you asked a question also regarding this.
Mm-hmm.
Okay. So
Mm-hmm.
my doubt is like, can you just repeat that question and explain it
Sure.
once? In short, sir, not an issue.
Yeah, no
In
issues.
short only.
So no issues. So basically, this box that I've created is just I'm visualizing a gateway. So basically, if I'm using a Zigbee at this point or a Bluetooth, these are the communication technologies. If I'm using a Zigbee or a Bluetooth, then these two technologies they cannot connect me directly to the Wi-Fi. Oh, sorry, to the internet. They must communicate with another Zigbee or another Bluetooth module. So here I have created two different sections just to demonstrate it. So this is a kind of gateway that we have. There are two parts. One is input, second one is output. We need to connect the output to the internet because that's what we want. We want to transfer our data from this complete hardware that we have at the perception layer. We want to transfer this data to the cloud, and Zigbee is a medium which will transfer the data to another Zigbee device, but it will not transfer it to the cloud. So we have used these three technologies, either one of them, to connect this particular gateway to the cloud, and then we are integrating this Zigbee. I'll just zoom in here and I'll write UART, so that Zigbee and Wi-Fi, these modules are connected to each other with the help of this interfacing protocol, which is UART. So that once the data is transferred from this Zigbee module to this Zigbee module, then from the wires it will transfer to this Wi-Fi module, and from Wi-Fi we have direct connection to the internet. Is it clear now?
Got it, sir. Yes, sir. Yes, I got it.
Okay. So
Sir,
now
another
let's
doubt.
talk about the different communication models in IoT.
Excuse me, sir.
So I'll erase all of this. Yeah. Hello.
Hello, sir. Another doubt.
Yeah, yeah. Please, please.
Sir, is the data representation in Zigbee and Wi-Fi modules different, sir? Is it different?
Uh, Data representation. I'm not understanding what exactly you want to say. Can you explain it? Like in
Uh,
what terms?
like for example, if we consider binary language and hexadecimal, like that, some
Okay.
machines understand one type of language like that.
So basically, it's like if you are transferring. So whatever the data that we are transferring, we are calling it as payloads. The data that we transfer between these devices or these modules, they are called payloads. So a payload can be in a form of a 256 bytes string or something like that. Not sure why am I muting myself again and again. Okay. Yeah. So basically, this.
Excuse me, sir.
Yeah.
Sir, what is the security level in these devices, sir?
Yeah. We'll talk about security, but first I'll answer that question. So if you have worked with any programming language, you have created variables, either a string type or integer type or float type. So we can make a data string and we can transfer it over a Zigbee or a Bluetooth module, but there has to be some limit, either 256 bytes or that depends from module to module. So once the data is transferred from one Zigbee to another Zigbee, then it has to be through UART we can directly transfer that string from one Zigbee to another Wi-Fi through UART. So it's like it's just the simple programming. You have to just select the variable and you have to transfer it to another variable, or you can just transfer it from one module to another module. Sorry, yeah,
Okay, sir.
let's coming to the security point of view. It's a very good question. Since Wi-Fi, if you guys have worked with the Wi-Fi and if you have read about IoT, it's stated that Wi-Fi is the least secure. So again, that totally depends on international standards that these different modules follow. Zigbee and Z-Wave and this BLE, they are secure in some terms if we use a gateway. Uh, and Wi-Fi is obviously less secure than these communication technologies. So security point is like it's totally depend on your server, what kind of server you are using, what kind of security parameters you are using, how you are securing it. That is another part. Hardware security is a at a hardware level there are different standards that these alliances follow. Zigbee Alliance, if you read about Zigbee Alliance, you'll find a lot of security measures that they take. If you read about this Wi-Fi Alliance, so you'll get to know about the security parameters individually for these different modules. There is internationally adopted standards as well, but on a cloud level it totally depends on the architecture. You need to take care of the security by defining your own architecture. In that particular case, you have to encrypt the payload that you are sending and then decode it again at the receiver's end. So that is again totally depending on your algorithms, what kind of algorithm you are building to transfer the data and stuff. Okay, so is it clear? Let's move to the communication models in IoT. Okay. Communication models. Okay, if you don't mind, I just want to switch to this application. I'm not very habitual to this whiteboard. I'll just go to the notes and then I'll start again. Just a second. Just a second. Just a second. Okay, this is fine. Yeah, please.
Then the IoT, you told there are three different layers: perception layer, network layer, and application layer. You discussed perception layer and network layer. So what
Okay,
about
okay.
the application layer?
I'm sorry. I must have forgot about
Yeah,
the
yes.
application layer. Okay, just a second. So application layer is basically where you define the application. It's not much big of a deal. In application, basically we have like what the the data that we have on the cloud, what kind of application we can derive out of it, either a GUI or a VUI, or GUI we can have this mobile application, uh, mobile app or dashboards. And in VUI, basically it's either creating applications for Alexa, for Google Assistant. How many of you guys have used Alexa and Google Assistant? So it's basically like interacting with your hardware. Either you can create an application for mobile, or you can create dashboards. And there is this VUI, voice user interface. One is graphical user interface. Alexa and Google Assistant, they both, or Siri, they all of them works on VUI, where you give commands to these different smart speakers, and they will perform action accordingly. If you say Alexa, turn on the light, it will turn on the light. Or similarly, if you say to the Google that turn off the fan, or change the AC temperature to 15 degrees, it will do whatever you say. So here the interaction mode is VUI. So application layer is just about creating applications out of that data. Either you can create dashboards for the industrial purposes, or you can create mobile application for simple purposes, for automation stuff, normal automation, individual user. And then you have obviously VUI, voice user interface. Now coming to the communication models.
Sir, I have one doubt.
Yeah, please.
Sir, is it necessary for all the communications to happen through cloud medium only?
Not exactly. That totally depends on your application, what kind of application you are, making. So if your application, if your product requires, internet connectivity, and once you use internet connectivity, that means your device or your product is accessible from anywhere in the world, right? So it totally depends on your product, the kind of application that you want to deliver out of it. Then you can maybe just depend on cloud. But if we talk about IoT, it's all about Internet of Things. That means, you connect the thing to the internet, and then you can access it from anywhere in the world. You can monitor and control it. So it's a better, practice to use internet, and use MQTTs and other things. So we will talk about this again, protocols and how to connect the things. And this might be boring for few students who are not interested in theory. But again, if I started from practical, you guys will not understand what I'm doing on the software part, or what I'm writing code in it. So I guess this is equally important as the practical lessons. So you guys must have an idea about how the things are working, what exactly is happening behind all these things. And if you have a clear understanding of the architecture, then maybe you can start building your own devices, and I'll provide you the platform to do that. Okay, let's talk about the communication models in IoT. First one is device to device communication. So again, this is an application of IoT in which one device, let's say this is a device A, directly communicates with device B, either via Wi-Fi or Zigbee, or we can say communication technology with any communication tech. So these devices, and this is also called M2M communication. So these devices can be connected to each other by means of any communication technology, either it be Wi-Fi, Zigbee, so or a GSM or LORA, anything. So I'll write it down here. What are the communication technologies? One is Wi-Fi, second one is GSM, third one is long range LoRa, fourth one is Zigbee, fifth one is Zeta waves, sixth one is BLE, then we have NRF, and then we have LAN. So these are few of the communication technologies. Another one is eSIM is also there. Sigfox is there. IoT SIM is also coming. NB IoT is there. So these are different communication technologies that we use in IoT. So first model is a very simple model, which is device to device communication. The one that you are asking, that if we don't involve internet in it. So this is the model where we don't involve any kind of internet connectivity. It's just the communication between two devices communicating with any of these communication technologies. Second one is device to cloud communication. Device to cloud. Okay, so here you guys need to pay a little attention, as I'll be relating it with a real life example. So let's say you have a smart home and you have multiple devices. You have a bulb, you have a different device that is TV, you have a different device, let's say LED, and you have another device which is a smart plug. So let's say if you have these four devices, and in this device to cloud communication model, all these devices directly connect to the cloud. There is no intermediate, any kind of gateway between them. Now, you need to understand a term here, which is called the lock-in. Vendor lock-in. So basically what happens is, this is just a practical explanation of what is exactly happening in the industry, in the IoT industry. Let's say if you are using a bulb from Wipro, and if you are using a TV from Samsung, and if you are using a LED from Philips, I'm just giving examples, and if you are using a smart plug from Havells. So these are the four different companies that you are using in your smart home, and you are connecting these four different devices to the cloud. And if you want to control the bulb, then you have to switch to the Wipro application. You need to go to your mobile, and then you need to open the Wipro app, and then you need to manually, just trigger the bulb to turn it on or to turn it off. Then if you want to access the TV, you need to download the Samsung application. Then if you want to control the LED, you need to download the Philips application. And in case you need to operate the smart plug, you need to download the Havells application. So these are just four devices, and your mobile also will be having four different applications for just the four devices. Now imagine if you have to purchase 50 of these different devices from, like, let's say 20 different other companies. Let's say Samsung is also manufacturing bulbs, so you got one bulb from Samsung. But in any case, not all the companies will be making everything. So you have to purchase different devices from different companies. So let's say if my home will be having like 5 to 10 or maybe more than that, 15 devices from different other companies, I have to download 15 different applications in my phone, right, to access each and every device. So that is a hassle, and that is this vendor lock-in method is there, in which vendor locks you to use a specific mobile application to control this particular device. Is it clear?
Yes, sir.
Okay. So again, device to cloud is normally connecting a simple device directly to the cloud without any gateway, but you are bound to use the application that is provided by a vendor. That is one thing. Now, to solve this issue, we have third model, which is device to gateway. Now, assume the same situation again. Device to gateway. Assume the same situation. You have four devices, A, B, C, and D. Now this device is from Wipro, this device is from Samsung, this device is from Philips, this device is from Havells. Now instead of directly connecting to the cloud, you have a gateway, and these devices are connected to the gateway first, and then they are either connected to the cloud by Wi-Fi, LAN, or GSM. Got it? Now these companies will also provide an application to control their specific devices. Samsung will provide its app to control Samsung, whatever is their TV or AC or whatever. Philips will also provide you application. Havells will also provide you an application. Wipro will also provide you an application. But at the same time, you can have multiple options. If we are using device to cloud, we are bound to use Wi-Fi. Wi-Fi has to be there. Wi-Fi, or Wi-Fi, or LAN, or GSM, because these are the only things by which we can connect any device to the cloud. But if we are using device to gateway, we can either use Zigbee, we can either use Z-Wave, we can either use Bluetooth, we can either use LoRa or whatever it is. But at the end, everything has to route from this gateway. Now, coming to the consumer point, we don't have to download the specific application. If I am using a gateway by XYZ company, I only need to download XYZ application, and I'll be able to control this device, this one, and this one. Or that I will be, connecting to this. So do you guys understand the difference between the device to gateway and device to device communication model and device to, cloud?
Yes, sir.
Yes,
Yes,
sir.
sir.
Is it,
Yes, sir.
yeah, any doubts in it?
No, sir.
No,
What you
sir.
have written this from Wi-Fi to last, like IoT you have written, no?
Pardon? Wi-Fi to?
So like the last word at the side of XYZ.
It's I have written 50 plus devices. Let's say if you use another 50 plus devices, you need to
That
connect
also
it to the
doesn't
gateway,
matter.
and then again,
Only we have to look after. We'll only download XYZ, and it will be common for us. Okay.
absolutely. You can also use software gateways as well. Uh, Again, I'll take the example of Google Assistant. You don't necessarily need to buy a Google Home, or Alexa hardware. They can also be, you can download the app as well. If you guys have used the Google Assistant, there are companies, or I can say the home automation brands, that supports Google Assistant as well. So Google Assistant is a kind of gateway, but it is a software gateway, not the hardware gateway. So it is a kind of gateway that connects all the devices, and you don't need to download even a single application. So if you are only using Google Assistant, that's more than enough. You can directly give commands to Wipro, Samsung, Philips, and Havells. SmartDen's devices, all of our devices, they also support Google Assistant and Amazon Alexa, but we work on a different model, so you don't need to purchase different appliances. We convert your existing to smart, so at the end of the day, we are creating kind of gateway. So for all your appliances, just a single application. That's our motto. Okay, so do you guys got the reference from Google Assistant?
Yes, sir.
Yes, sir.
Yes, sir.
If you look at all the automation companies, or all the home automation brands, or all the IoT products, you must find that there is a label on them which says supports Google Assistant and Amazon Alexa, supports Google Assistant and Amazon Alexa. So it's the same thing. All those devices from different brands, they support Google Assistant and Amazon Alexa, and you can control everything with just voice commands. So that's how these thing works. So we've studied about device to device, device to cloud, and device to gateway communication model. Everything is clear, I hope.
Yes,
So,
sir.
Yes,
Sir,
sir.
one question.
Yes, sir.
Yeah, please.
so what is the
Sir, Zigbees and
compatibility?
XBees are same.
There are two questions coming from two guys. Can you ask one by one? Likhit, I guess you were asking something.
No, sir, I wasn't asking. The other two guys.
Okay, can I ask?
Yeah, sure. Please go ahead.
Yeah. So my question is, how much friction is there between these home automation companies and these individual companies which are like going for these ecosystem-based IoTs within their own this thing? Because each of them want to like further advancements in IoT technology within their own companies, but
Okay.
like
Yeah.
if they do not want to, you get my question, right?
Yeah. So basically,
So between
So what we are doing, again, I'll take my example, since we are in the same business and we are doing the same thing. So
Right.
let's say if I don't integrate Google Assistant and Amazon Alexa, in that case, I'm restricting my audience to use my devices only. But Google Assistant and Amazon Alexa, they are also restricted to, they also restrict the user to perform a limited operations on the devices. So if I give you an example, let's say there is, again, simplest example is of LED. If I integrate the LED with Google Assistant, I can only perform on and off. That's it. But the same LED, if it is connected with SmartDen application, and if I'm controlling it with the SmartDen app, I can also control, like I can also perform this on and off. Apart from this, I can create scenes, I can create workflows, I can check the history, I can check the power consumption, I can check the number of running hours, I can add this switch to NFC, I can schedule it to turn on or to turn off at a particular time. So you see the difference here. When you use a specific application, and I'm not just talking about the SmartDen app, either you use a Samsung TV and you are using it Samsung's application, so you will have access to a lot of features that Google Assistant or Alexa will not provide you. They will only do the basic thing for you, on and off. You cannot just ask Google to, schedule my LED to turn on at 10 a.m. in the morning. So that might be happen in future, but again, as of now, the point of interaction is very simple. You can only create scenes in Google Assistant, but that can be triggered from the Google app itself. But if you use a vendor specific application, you will get a lot of things. You can create scenes, workflows, you can check the history, who has turned on the appliance, who has turned off the appliance, you can check the power consumption, you can check the running hours, how much time this appliance is running. You can use the NFCs in our app only, basically. So this is a new feature that we have introduced. You can also create schedules to turn on or to turn off a specific appliance to at a particular time. So that's the difference between using these assistants or these third party Google Assistant, Alexa, and the vendor specific application.
Right, makes sense.
Yeah, thanks. Any other questions?
So
Yes,
yes, sir.
sir.
Regarding
Mhm.
the gateway, sir.
Yeah,
You said Google Assistant is an example of a software-based gateway. So,
absolutely.
if we how do we know like what is the criteria for being compatible for a specific gateways? Like here we are using Zigbee and
Mhm.
all the other, and we are connecting it to the Wi-Fi and LAN. So there
Okay.
should be some compatible criteria based on which device can be allowed. Like few Samsung TV won't be compatible to the gateway.
టీమ్స్ లో
So
లాగిన్ అవ్వచ్చు కదా మీ సిస్టమ్స్ లో చేయండి లేకపోతే
uh, there is some kind of voice coming from. Okay, yeah, so can you repeat the question again? What kind of compatibility you are asking?
yeah, like what is the compatibility criteria for the gateway based on which we can
So
decide like this device can be connected to the gateway and this can't be.
So the criteria is simply the communication technology itself. So there are gateways for Zigbee only. There are gateways for Bluetooth only. There are gateways for LoRa, long range only. So that totally depends on the gateway manufacturer. I can be a gateway manufacturer and I can just make a gateway for Zigbee so that all the devices that support Zigbee can communicate through my gateway. So it's basically like for which kind of communication technology you are creating a gateway. You can also create a gateway that supports multiple technologies like Bluetooth, Zigbee, Z-Wave. So yeah. So there is again no as such compatibility issues. If your device supports Zigbee, then the gateway, and if the gateway is supporting the Zigbee, then they can communicate easily.
Yes, sir.
So as a general rule, we can say that the more the different gateway communication models there are, the more integrated the different systems and appliances and gateways can be, right?
I lost you. I lost you in the
As it
middle. Can you please repeat? I lost your voice.
right. So what I was saying is that so the more as a general rule, the more the number of gateways and other systems in place for the communication between these appliances, the better, right?
Yeah, communication can be better. Gateways are a lot useful as seen from security point of view as well, because gateways provides an extra layer of security in the complete network, and they also provides the connectivity part. The range of a gateway is definitely much better than the range of a normal Wi-Fi. And the topology it supports, gateway will also support the mesh topology. So yeah, we have a wide spectrum of devices as well. And in a same infrastructure, let's say if I'm using multiple devices from multiple technologies and multiple brands, so gateway will obviously increase the bandwidth of the devices that I'll be using. So I can, if I'm having a gateway, I can use Zigbee devices, LoRa devices, or BLE devices depending upon the gateway I have. So yeah, it obviously increases the overall, bandwidth of the complete network. Yeah.
Right.
So,
Sir?
any questions? Any other questions?
Yes, sir.
Yeah,
Sir,
please.
are Zigbees and XBs same, or are
Yeah,
they
yeah.
different technologies?
XBs and Zigbee, they are the same thing. Zigbee Alliance is a different, alliance that is formed specifically for Zigbee. Uh, so yeah, they are same things. XB
They
is a
cannot
module basically.
communicate between each other. If Zigbee and XBs are connected to each other, can they communicate or they cannot?
Yeah, they can communicate. They can communicate with each other. XB is a module, I guess. I haven't worked with XBs, so but I guess Zigbee and XB they are the same thing and they can communicate.
Thank you, sir.
So basically, I've worked with Wi-Fi's, NRFs, and Bluetooth modules, and am I audible? Am I audible properly? It's saying sound
Yes,
quality is
sir.
bad.
Yes,
Okay.
sir.
And our devices that we have built, they are all on this Wi-Fi protocol, and we are shifting towards Zigbee, and we are introducing gateways in near future as well.
We
Any
said
other?
we
Yeah, please.
so we also say that the modems which we use in our houses, they consider both Zigbees and Wi-Fi's.
No, modems that we are using, they are only Wi-Fi based. I haven't seen any Zigbee based modem yet.
How we should input the devices in our modem? How we
Uh,
translate our data from that?
See, modem is a kind of gateway in itself. If you look closely to a modem, it converts your LAN to the Wi-Fi. So you are getting a cable connection and you are putting a Ethernet cable in your modem, and then you are accessing the Wi-Fi on your mobile device. So it's kind of a gateway. But if I talk about modem specifically, I'm not sure what kind of Wi-Fi module they are using. So you first have to open up the modem, and then you have to check the module. Then you have to figure out these interfacing protocols, and then you need to connect your Zigbee module to that. So each and everything is possible again, but you have to figure out different ways of doing it.
Correct. Thanks.
So we will be working on Wi-Fi module in, I guess, tomorrow. Let's keep this session in the evening, and uh, tomorrow I'll be taking more than 1.5 hour or maybe 2 hour class, so that I can show you how these things work. We will work on MQTT protocol as well. So it's 11:18, I guess, and I have to leave early today. But don't worry, we'll be working, and we'll be also completing a project itself. We'll be using temperature sensor with ESP modules, and we'll be transferring the data to the cloud where we can access that data. And we'll be creating a smart LED which can be controlled from anywhere in the world. And we have an application that we have created for all of you, which is SmartDen.tech. You guys can use that application. You guys can make your modules, IoT devices, and you can just all the codes and all the stuff we will provide you. So it's very easy to use. So you guys will love it, I'm sure. So I guess if you don't have any questions, shall I leave and we'll connect tomorrow again?
Sir,
Yes, sir.
Yeah, please.
sir, in application layer, there you didn't explain much. Can I know what is the research gap in application layer
Uh,
in
in
terms of security?
Application layer is basically, once you have the data and the in the cloud, it's basically using that data accordingly. I mean, in the IoT, we have like three different kind of applications that we can build. One is the mobile app that we have built for specific users. Let's
Yes.
say if I'm using a home automation system, I'll be accessing that home automation system with the mobile application itself. So what mobile app is one. Second one is your dashboards. So if I'm using if I'm using or if I am owning a factory, or if I am automating a complete enterprise, then in that case I have to provide a complete dashboard with analytics and with artificial intelligence, to monitor all those assets that we have in an enterprise or in a factory or in an industry. So to monitor that, we can develop dashboards as well, And again, if we're going to user specific applications, we have these VUIs nowadays, which which interact with your device through voice commands only, like Alexa and Google.
Okay.
So yeah.
Okay, thank you, sir.
So any other questions, or any other questions from anyone, or shall I leave?
No, sir. Thank you, sir.
Sir, when will
Thank
we
you, sir.
discuss
Okay,
about
then
the security?
I
Sir,
guess
are there any notes?
this is it. Pardon? Hello, can you
Sir,
repeat?
when will we
Are we going to get
discuss
like
about
any?
security?
Again, two of you are asking questions simultaneously. Can you ask one by one? Yeah, Abbas, you were speaking something. Can you
Sir,
guys ask
should I
one by
go for
one?
it?
Yeah, please go for it.
Okay. Sir, will we be getting any drive link for like having notes or something? As well as can we have a practice link where we can actually practice regarding the IoT?
Practice link I'll share tomorrow. Basically, what I'll share tomorrow is a GitHub link of a GitHub repository of our tech platform, and I'll share you the complete resources of that particular platform. And it's basically a free to use platform for anyone. So yeah, you can just have a look, and you can create your IoT devices there. I'll be helping in teaching you stuff. And also, if you want more sessions on IoT, I'll share one my channel's link. I also have created multiple videos on YouTube. So if you guys want to learn more about IoT, Node-RED, how to these things work, and what exactly are these protocols in major detail.
Surely share.
So I'll share that as well. So okay, so I'm going to share it right away. Just give me a second. I'll search it and I'll put it in the chat. I'm not much active on YouTube, but yeah, whenever I get time, I'll post some videos.
So the thing is, not the meeting settings haven't been set properly, so not everyone has access to the chat box.
Okay, no issues. I'll share with Rashi, and then she'll spread across.
Yes, sir. Yes, sir.
Okay, perfect. And don't worry. I'll be available on LinkedIn as well. You guys can search me by Shrey Sharma, and I'll be there. Okay, I guess that's it for the day, and let's meet tomorrow, and we'll do some practical. Theory is, I guess, बहुत हो गया theory. We'll do some practical work. We'll start with Arduino. We'll see the basic concepts of Arduino. Then we'll start with ESP. We will learn about MQTT protocol. We will work on MQTT libraries, and we will see how we can connect our devices to the internet. So I hope that sounds good.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so thanks a lot. Thanks a lot, everyone. And
Thank
I'll
you,
see you
sir.
tomorrow.
Thank you, sir.
Thank you, sir.
I'm not taking it as a formal class, but yeah, I hope you guys are learning something out of it.
So thank you
Yes,
so
sir.
much.
Yes, sir.
Yes, sir. Yes.
Thanks a lot. Thanks a lot,
Sir,
everyone.
1 minute.
Thank you, sir.
Thank you.
Thank you, sir.
Thanks a lot.
Let's uh, thank you so much, sir, for such an insightful and enlightening session. I hope there was a lot to learn for the audience today. Also, we would now like to open the floor for questions. If you have any questions, please unmute and ask the sir. I guess all the doubts are cleared. So, I would now request everyone to switch on their cameras for a group photo. Hello. Hey guys, please turn on the cameras. We just Hello, am I?
Yes, yes, you are.
Yes, yes, please. Yeah, please turn cameras on so we can take a snap. Yeah, thank you so much, guys. Again, I would like to extend my heartfelt gratitude to you. Also, I would like to thank all the participants for joining us today. It was really wonderful to have you all here. And now, with this, we would like to close today's session. Again, thank you so much for joining us for today's session. And we have tomorrow session at 1 o'clock.
Thank you.
Thank
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Yeah.
Thank you.
Guys, meeting is over. You can leave now. Actually.